In this video, we're going to look at some examples of naming and writing formulas of binary ionic compounds. Binary ionic compounds, as the name suggests, are just composed of two types of elements. They'll be composed of a metal and a nonmetal. The rules for naming these compounds are relatively straightforward. We state the name of the metal first, and we just write down the name of the metal. If it's a metal that only has one possible oxidation state just means charge, then we don't have to specify what the charge is. And the metals of which we know the oxidation state, we know the alkali metals are always +1, the alkaline earth metals are always +2, and then the other three metals on the periodic table where we know what the oxidation state is always going to be, aluminum is +3, zinc is +2, and silver is +1. If the ionic compound involves a metal that doesn't fall into these categories, then it can have multiple possible oxidation states or charges. When that is the case, then the charge of the metal needs to be specified after its name using Roman numerals. Finally, we name the nonmetal, and we replace the suffix of the name of the nonmetal with IDE. So let's look at a couple of examples. All right, the first thing we're going to do is we're going to write the formula based on the names that were given for the ionic compounds. Now, typically what we want to do here for ionic compounds is to write down the charge of both the metal cation and the nonmetal anion. So for calcium chloride, calcium is an alkaline earth metal, so it's in the second column of the periodic table. So we know that the alkaline earth metals have a charge of +2. Chlorine is a halogen. It's in the second to the last column of the periodic table. So we know that the halogens like to have a charge of -1. So the way we determine the formula for this compound is the charges have to balance out. The whole thing has to add up to be neutral. So in this case, if calcium is +2 and chlorine is -1, I need two chlorines to balance out the +2 of calcium. The other thing that we can do, a trick that often works, is we can swap the charge on one atom for the subscript in the formula of the other one. So in this case, the calcium gets a 1, the chlorine gets a 2, and so the formula for this compound is CaCl2. Let's look at another example. So we want to write the formula for titanium 4 oxide. So the 4 tells us the charge on the titanium, the charge on the metal atom. The reason we need to specify the charge is because titanium is not an alkali metal, it's not an alkaline earth metal, so it can have multiple possible oxidation states. So when we name the compound, we have to say what is the oxidation state, or what is the charge. In this case, titanium has a +4 charge. So when I want to write the formula, I start by writing it's titanium +4. Oxygen is in the second to the last column of the periodic table, so nonmetals in that column like to have a charge of -2. So in this case, when we want to determine the formula, we see that titanium is +4, oxygen is -2, so we need two oxygens to balance out that +4 charge. If we do the trick where we swap the charges for the subscripts, we would get Ti2O4. And that's different than the TiO2 that I just said. So if we can reduce the subscripts, we want to do that. So we want the smallest whole number ratios in the formulas for these ionic compounds. So 2 and 4 are both divisible by 2, so we can reduce it. So the correct formula for titanium 4 oxide is TiO2. All right. Finally, we want to give names to these binary ionic compounds given their formulas. So in the first case, I have sodium and sulfur, and we'll change the name of sulfur to sulfide. In this case, because we know the charge on sodium, sodium is an alkali metal, it's in the first column, so I don't need to specify the charge in its name. So I can simply write that it is sodium, and then I change the suffix of the nonmetal to IDE, so it's sodium sulfide. For the second ionic compound that we need to determine the name, we have uranium and oxygen. Now, uranium is not one of the metals that we know what its oxidation state is going to be all the time. So when I name the compound, I have to specify what its charge is. So whenever we encounter this, we have to use the non-metal to figure out what the charge is on the metal. So I like to write a little algebraic formula to figure that out. And so we know that the compound has to be neutral. So whatever the charge on uranium is, I've got 1 uranium, and I've got 3 oxygen atoms. And we know from the previous slide that oxygen likes to have a charge of -2. So each one of these oxygens is a -2. So I've got 3 times -2, and that adds up to be 0, because I want the compound to be neutral. So now I just have to solve for what is the charge on uranium. So I've got U minus 6 is equal to 0, so the charge on uranium is +6. So now I'm ready to name my compound, because now I know the charge on uranium. So it's uranium 6 oxide. And again, the 6 refers to the charge on that metal cation.